The journey of sunflower oil begins far away from the factory. In vast open fields, where nature and sunlight work together to create one of the most oil-rich seeds on Earth. Sunflowers are not just visually striking plants. They are carefully cultivated crops, grown specifically for their high oil content. Farmers select premium sunflower varieties that are known for their strong resistance to disease, high yield, and excellent oil quality. These fields are prepared months in advance, with soil tested, nutrients balanced, and irrigation systems planned to ensure optimal growth. As the sunflowers grow, they absorb sunlight throughout the day, converting solar energy into oil stored inside their seeds. This natural process takes weeks of precise care. Farmers monitor soil moisture, weather conditions, and plant health daily. At the final stage of growth, the bright yellow petals begin to dry, and the sunflower head tilts downward, signaling that the seeds inside are fully mature and packed with oil. Harvesting is a race against time. If done too early, the seeds lack oil. If delayed too long, weather and pests can damage the crop. Modern agriculture relies on massive harvesting machines designed specifically for sunflower crops. These machines move in perfect alignment across the fields, cutting sunflower heads, separating seeds, and collecting them efficiently in a single pass. Inside the harvester, rotating drums shake loose the seeds, while fans remove excess plant material. The result is a continuous flow of sunflower seeds collected at an industrial scale. Once harvested, the seeds are immediately transported to the oil processing factory. Speed matters here, because freshness directly affects oil quality. Trucks loaded with tons of sunflower seeds arrive at the factory gates, where the transformation from agricultural product to refined oil begins. The first stage inside the factory focuses on cleaning. Although the seeds appear clean from the field, they still contain dust, stones, small sticks, metal fragments, and broken shells. These impurities must be removed completely to protect machinery and ensure food safety. Advanced cleaning systems use a combination of vibrating screens, air blowers, gravity separators, and powerful magnets. Air currents lift away lightweight debris, while heavier stones fall through gravity channels. Magnets capture any metal particles that could damage equipment. By the end of this stage, only clean, uniform sunflower seeds remain. Next comes drying, a critical but often overlooked step. Sunflower seeds naturally contain moisture, which can interfere with oil extraction and reduce shelf life. Industrial dryers gently reduce moisture to precise levels without overheating the seeds. This process is carefully controlled, as excessive heat can degrade oil quality. Warm air circulates through layers of seeds, slowly and evenly drying them, while preserving their internal oil structure. After drying, the seeds move to dehulling machines. Sunflower seeds have a hard outer shell that contains very little oil. Removing this shell improves extraction efficiency and produces a cleaner oil. Dehulling machines crack the shells using high-speed impact and pressure. Air separation systems then blow away the lighter husks while the heavier kernels fall onto conveyors. These husks are not discarded as waste in large factories. They are often used as biomass fuel to generate energy, helping reduce overall environmental impact. Now the process enters the mechanical phase. The clean, dehulled sunflower kernels are fed into crushing mills. Heavy roller mills flatten the kernels into thin flakes. This step dramatically increases surface area, making it easier to release oil during pressing. The crushing process is smooth and continuous, with machines calibrated to produce flakes of uniform thickness for consistent results. The flakes then pass into conditioning units, where they are gently heated and mixed. This heating is not meant to cook the seeds, but to soften the oil-bearing cells inside. Controlled temperatures allow the oil to flow more freely during pressing, while preserving its natural characteristics. Steam may be introduced at precise levels to improve pliability. This conditioning step plays a major role in maximizing oil yield. From here, the prepared sunflower flakes enter the heart of the extraction process, mechanical pressing. Massive screw presses dominate this section of the factory. Inside each press, rotating screws apply intense pressure as flakes move forward through narrowing chambers. As pressure increases, oil is forced out through tiny perforations in the press walls. The oil flows downward as a thick, golden liquid, while the solid material continues forward. This moment is where the sunflower truly becomes oil. The extracted liquid is rich in natural compounds, nutrients, and aroma. However, it is still considered crude oil and requires further refining later. For now, the focus is on efficient extraction. What remains after pressing is known as sunflower meal or press cake. This compressed solid still contains valuable nutrients, especially protein. Rather than being wasted, it is broken into smaller pieces and transported for use as high-quality animal feed. This complete utilization of raw material is a key feature of modern sunflower oil production. In large-scale factories, mechanical pressing alone does not capture all available oil. To achieve maximum efficiency, the pressed sunflower flakes may undergo solvent extraction. This process uses food-grade solvents to dissolve remaining oil trapped inside the solid material. The solvent-oil mixture is then separated, and the solvent is carefully evaporated and recycled. This ensures that almost every drop of oil is recovered without compromising safety. The oil collected from pressing and solvent extraction is combined and filtered to remove solid particles. At this stage, the oil has a deep golden color and a strong sunflower aroma. It contains gums, waxes, free fatty acids, and pigments that will later be removed during refining. Still, This crude oil represents the successful completion of the first major phase of production. From open sunflower fields to high-pressure industrial machines, this entire process is a remarkable blend of nature and technology. Each step is designed to protect oil quality, increase efficiency, and minimize waste. By the time crude sunflower oil leaves the extraction section, it has already passed through dozens of machines, each playing a critical role. This is the foundation of sunflower oil production. Everything that follows, refining, purification, and packaging, depends on the care and precision of these early stages. Without proper harvesting, cleaning, conditioning, and extraction, high-quality sunflower oil would not be possible. After the extraction phase is complete, sunflower oil has taken its first physical form, but it is still far from the clear, neutral, and stable cooking oil found in stores. At this stage, the oil is known as crude sunflower oil. While rich in natural components, it also contains impurities such as gums, free fatty acids, waxes, pigments, odors, and trace elements that can affect taste, appearance, and shelf life. The refining process exists to transform this raw liquid into a clean, safe, and consistent product suitable for everyday use. The refining journey begins with degumming. In crude sunflower oil, phospholipids, commonly referred to as gums, are naturally present. These compounds can cause cloudiness and instability if not removed. In large factories, controlled amounts of water or food, grade acids, are mixed with the oil. This causes the gums to hydrate and separate from the oil. High-speed centrifuges then spin the mixture, forcing the heavier gum particles outward, while the clean oil flows forward. This step significantly improves oil clarity and prepares it for further purification. Following degumming, the oil enters the neutralization stage. During extraction, sunflower oil naturally develops free fatty acids, which can give the oil a sharp taste and reduce its storage life. To remove these acids, the oil is treated with a mild alkaline solution. The free fatty acids react and form soap stock, which is then separated using centrifuges. This process stabilizes the oil, improves flavor, and enhances its resistance to oxidation. The soap stock byproduct is often recovered and reused in other industries, ensuring minimal waste. Once neutralized, the oil is washed with clean water to remove any remaining traces of soap or chemicals. It is then carefully dried under controlled heat and vacuum conditions. Moisture at this stage could negatively impact the next refining steps, so precision is essential. Sensors constantly monitor temperature, pressure, and moisture levels to maintain consistency across massive production volumes. The next major step is bleaching. Despite its name, bleaching does not involve harsh chemicals. Instead, natural bleaching earths and activated carbon are mixed with the oil. These materials act like powerful sponges, absorbing unwanted pigments, trace metals, oxidation products, and residual impurities. The mixture passes through fine filtration systems that trap the used bleaching agents, leaving behind oil that is noticeably clearer and brighter. This step gives sunflower oil its clean golden appearance and improves its overall stability. After bleaching, the oil moves into the deodorization stage, one of the most critical steps in the entire refining process. Even after purification, sunflower oil can retain natural odors and flavors that are undesirable for cooking. Deodorization removes these volatile compounds using steam distillation under high vacuum. The oil is heated to carefully controlled temperatures while steam passes through it, carrying away odor, causing molecules. The vacuum environment allows this to happen without damaging the oil's structure. What remains is a neutral, tasting, odorless oil suitable for a wide range of culinary applications. Once deodorization is complete, the oil is rapidly cooled to preserve its refined quality. It then passes through final polishing filters that remove any remaining microscopic particles. At this stage, the sunflower oil has achieved its final form, clear, stable, mild in flavor, and visually appealing. Quality control now becomes the focus. Samples from each production batch are tested in on-site laboratories. Technicians analyze color, acidity, moisture content, and oxidative stability. Sensory tests ensure the oil has no unwanted taste or smell. Only batches that meet strict quality standards are approved for packaging. Approved oil is transferred to large stainless steel storage tanks, where it is protected from light, air, and contamination. From there, automated bottling lines take over. Bottles move along conveyors at high speed, where they are precisely filled with sunflower oil. Machines seal caps, apply labels, and print batch numbers and expiration dates. The entire process is designed for efficiency, accuracy, and hygiene. Different packaging formats are produced depending on market needs. Small bottles are prepared for household kitchens, larger containers for restaurants, and bulk packaging for food manufacturers. Each package is carefully inspected to ensure there are no leaks, labeling errors, or defects. The final stage involves palletizing and warehousing. Finished products are stacked, wrapped, and stored in climate-controlled environments before being shipped worldwide. From this point, sunflower oil begins its journey to supermarkets, restaurants, and homes across the globe. Through refining, purification, and packaging, crude sunflower oil is transformed into a trusted cooking essential. Every step is guided by science, technology, and quality control, ensuring that the oil reaching consumers is safe, consistent, and reliable. What began as seeds grown under the sun now becomes a refined product ready to support millions of meals every day.